Okay, let's start. The topic of today's lecture is Introduction to Coding Classification and the Medical Application. So it's a little bit complicated area with a lot of theoretical questions have to be considered. But still we have to pass through somehow. First of all, I want to talk about some basic as introduction of classification topics and objectives and necessity to be used in healthcare area. Then will be a large theoretical section about basics of classification process in generally different backgrounds in classification process, and then a brief overview of most common medical classification systems. Let's start with our first topic, this first question of our lecture. Generally about understanding what is classification and its necessity. So for decades, if not 100 years, traditional patient records data were available in written format only. So like free text with some numerical data. It's more recently when laboratory results become available. So as a result, the construction of patient history from such handwritten records per clinician, it's usually not easy task and hindered by fact that many medical terms are ill-defined and perhaps even ambiguous. So it was actually, to take a look into Ukrainian healthcare, it was a problem even, let's say, less than 10 years ago. Still, most of records were in handwritten format, in free handwritten format. But change had started to, things had started to change with development of information system and with wide implementation of information system. And as part of it, like not exactly consequence, but even rather some meanings predecessor of it, it was a process of development of coding system for medical purpose. Generally, medical coding is a process of assigning standardizing medical codes like numerical mnemonic to patient records chart. And encoded information used to standardization of content. Then, so it was why I put this in this order, because actually medical codes, basic medical codes, they prepare development information system. So primary objective was standardization of medical content. But with development of an implementation of medical information system, we got extra benefits from standardized content. We get chance of establish interoperability between different information systems and exchange data between such systems. So, and after that, we have extra benefits like sharing data between different like insurance companies, government, World Health Organization, accurate billing, list of services, and etc., etc. So, but here is we have two primary options, two primary benefits: standardization of content and establishing interoperability. Actually, here is we have left side general free text written medical records, and right side still paper version, but with well-established structure and with supporting of providing some standardized terms and definition. Still, actually, of course, if we talk about left-hand side representation, it's, despite it's at least divided into some section, it's extremely difficult to reconstruct things. So as I already said, Ukraine had used something similar to this even about 8 years ago. Right side, we have form which could be many section, just selected proper like checkbox or entered noun codes like this, but still it contain section to be completed, to be handwritten. And actually, even this case, even such form sometimes could be filled in such a way that make it usage not very easy. So in contrast, when we have ability to provide encoded information, we say ability to fill electronic medical records with standardized content like at the right side. And here is, we eliminate any ambiguous components, and we have our medical data clear to be used by any physician, as well as to being sent to another facilities in case of necessity, in case of interoperability established between systems in country. So in generally, when we talk about interoperability in healthcare, it's ability of different information technology system and software application to communicate, exchange data accurately, effectively, and consistently, and use information that had been exchanged. So, on the way to establish interoperability, we have to pass through understanding of levels of data structure, not only in medicine, but generally. So first of all, we talk about non-electronic data like paper documents, including medical history, paper mails, and let's say analog voice calls, old voice calls. So second level, so it's actually barely possible to manage such content in electronic way, in digital way. Second level, it's machine transportable data, means fax, mails, and unindexed documents. There we can ability to send it to conventional communication channel, for example, that same email, or sharing an indexing document with any services like Google Docs or so, but still content not the same. And here is second, third, and fourth level, which had been introduced along with L07 international standards, which first of all allow to bring some initial order into our unstructured digital document. So at the first level of automation, it was introduction so-called machine disabled data, structured messages, and structured content. Means each, for example, an unindexed, unstructured document had been augmented by some standardized message header, which provide necessary indexes information about what kind of content represented by this document. So it was a huge leap forward, and it allows to establish first level of interoperability between information systems, specifically medical information system. It was like at the end of 20th century happens. And in more recent time, we move to the fourth level, which include machine interpretable data with structured messages and standardized content. So in this case, we retrieve ability to automatically transfer from external lab of coded results into, for example, EHR. So automatically retrieve results from medical examination from laboratory and fills this in the appropriate data records of electronic medical records and so on. So here is we have about full automation, and also we have further benefits like semantic interpretation, translation, and so on. So all these things we already achieve. We got by from fourth level of data type representation. And what is actually HL7? I'm already mentioned. It's national standards which developed, which was established to enable interoperability of healthcare data information. Its organization has been founded in 1987, initially focused on interoperability among information system within large hospitals. So, because by that time, usually hospitals had been equipped not by one but multiple information system. It was very challenging task to establish data exchange between him. And later, organization began focusing on interoperability among systems in disparate organization, including public health. So, in fact, here is we have some historical steps. It's actually not ended up by 2004. It's even by now, it's represent major international standard for health information exchange. But here is actually we have, let's say, early history of development. Still, you can see how different steps, how different version of the standards has been published, developed and published, and how we have different variation on these standards, like 3 major version, CDA architecture, then syntaxes, which I also already mentioned in the previous lecture, and so on. Actually, we have even modern version of formats for data exchange under HL7 now. But before I will introduce it, I want to just make an emphasis how it works, in fact. Why do we need it? So usual in modern time, usually when we need to exchange health information between different facilities, let's say laboratory and hospital. So here is we have like sender laboratory system made a request about, let's say, patient data to process with specimens. It has to be format request in some specific format, and it has to be in modern time exactly HL7 encoded message, which then sent to any communication channel to the receiver, let's say hospital information system, which have to be able, which definitely will be represented by different kind of information system, probably different vendor, version, etc. So it has to be capable to pass request, retrieve critical parameters from there, process data, like prepare necessary record to be represented as response, then encode it again into HL7 format, appropriate HL7 format, then send back to requested information system, which again, in turn has to be able to parse response and process it, like add the newly calculated laboratory test results to the record. And then again, cycle loop will be repeated, the data will be sent back to the hospital computer, and so on. So here is we have at least 4 places where HL7 messages of different formats could be utilized. Modern concept of all modern concepts of HL7 standards based on so-called clinical document architecture, or CDA, which is electronic equivalent of paper documents, and contain two general major parts. Header, which contain encoded information about service information about this document, like subject data, encoded patient information, encoded physician information, facility information, different encounter, date, and so on information, and body of information, which in fact has to be human readable information, augmented by computer consumable data information in terms of various object identifiers and so on. So as a result, this general architecture, CDA, practically implemented on the different type of format within life cycle of HL7 development. So here is when we will dump conventional HL7, we will try to dump conventional HL7 message at like barely visible here, but I have not found something better. I mean printed, because usually it's never printed. So it's barely possible to be reconstructed. In contrast, with help of information system, this could be easily both composed as well as decomposed, reconstructed, and processed. So here is example, a few examples how it's look like. Let's say encoded HL7 second version, very early version messages. As you can see, it contains some readable information, like some patient name or so. And it's mostly, yes, it's mostly text-based, but consists of multiply extra coding words, abbreviations, and so on, which actually establish a sequence of OV2 messages. Most recent implementation of HL7, which had been adopted in 2017, first time created 2015 and adopted in 2017, and it's in active development by now. It's FHIR, or Fast Healthcare and Regulatory Resources. So it actually allows to, it still has the same purpose, to establish interoperability between different information systems, but it introduced approach which is already used in over internet as part of World Wide Web, so-called API, Application Programming Interface, which based on, here is at the bottom, we have the represented structure of typical request, which is actually fulfill general web approach to data processing. So it contains some request, headers, and body content, which carry on information. So major concepts of here, it's so-called resource, which is common healthcare concepts like patient, medication, diagnosis, or some, let's say, encounter, and specifies how to represent the exchange of this data. And next important point is its flexibility, which is consists of modules, so it could be adopted to a wide range of clinical and administrative use case, so we can transmit any kind of information we need within it. And actually here will be some depiction of evolution, different type of HL7 messages. So I have already shown for you V2 message, which is text-based, contain many readable part, but it's a lack of flexibility, in fact. They were tried to replace it, attempt to replace it at the end of 20th century, beginning of 21st century. It was attempt to replace it with XML notation. That's equivalent to HL7 V3 type of messages. It was much more flexible, but as you can see, it's barely readable. So, and here we have at left side FHAR implementation. So first of all, above at the left top, right top, for you shown like representation of patient resource, which could be encoded in different way. But major approach to encoding resource is JSON. Or JavaScript object notation. As you can see, it's combined both better features of previous formats. So first of all, it contains, it's well structured. We have like tree-like hierarchy of objects, hierarchy of string pairs, and each pair represent like a property, definition of property and its value. And value of properties usually readable. So here we have like combination both best features of previous HL7 V2 as well as V3 format with well-structured features of JSON format. So here is how look like data exchange packages between medical information system now. And what is important that all major IT vendors, all major players already adopted it, and even non-healthcare organization support data processing in this format, like Google and Microsoft. They both support this API and provide their services which could interact with this kind of data. So it's become really worldwide adopted by now. Same way, open source solution for medical area, like our major open source medical information system, medical information platforms already adopted and support that data exchange within this format. Not with latest format, not only this one, but actually they support previous as well. Take a look about OpenMRS. They spoken about, they still support like V2, partially V3, and so on. So here is backward compatibility still available even in the area of open source. Okay, and now we so as a result, before we move into next question for our lecture, let's brief summary about benefits of coding medical data. It's data reduction, it's standardization of terminology, its ability to be implemented easily within electronic medical information system, its capabilities for interoperability, and other features like support management planning, statistical processing, etc. So, of course, it comes with some obvious risks. For example, when we have well-encoded data in different platforms like non-healthcare platform, I mean those Google, Microsoft. So we have at risk of data leaks, of course, but it's like kind of price have to be paid for advances, I think. And then before we move into further question of our lecture, just I want to show how broad is the area of medical standardization and coding processes. So here is like links of, here is shown, if you will download PDF version of this presentation, you will see links to you'll be able to navigate to these links to individual just overview articles about different aspects of standardization and coding, which is related to healthcare area. So there are available things I already mentioned on here, L07, but here is we have number of different concepts and topics which have to be studied in order to have like understanding of field of coding of application of standards codes in the healthcare area. So in the next part of lecture, I will try to like get back to the beginning and provide some introduction about what's make all this possible. I already spoken. So what is coding? How it can be? What's coding? What's classification? And how all this could be assembled, combined in order to develop medical coding classification systems, which at the current time lead to those all digital marvel data exchanging standards. So in second part of lecture, I will talk about classification definition in general, not only in relation to medicine and healthcare. Then purpose, concepts, ordering principles, and then definition of related and differences between things like thesaurus, codes, nomenclaturas, ontology, and so on, etc. So when we talk about classifying, it has two different meanings. So process of designing classification and coding or description of an object by using codes or terms that are designated concepts and classification. In fact, in first part of lecture, I actually mentioned second meaning of this. I actually had already spoken about application of classification system, coding classification system. So right now, I'm going to make step back, and we will talk about first question, design and classification system. So classification is an ordered system of concept within a domain with implicit or explicit ordering principles, any domain, any area. Not only medicine. Classification based on prior knowledge and forms a key to be extension of knowledge. So we have to already collect some knowledge. We have to have some like heap of information which we need to bring in order. And this order is classification. So when we put our unsorted like bin of knowledge into some classification system, arrange it in some order, we will be able to continue gain new knowledge to extend our knowledge. So purpose of classification is, for example, to support the generation of healthcare statistics or for state research. If we talk about, let's say, medical classification system. And as kind of example classification, it could be classification of abnormalities of ECG or diagnosis of patient into diseases classes and so on. In case if we talk about abnormalities of ECG, it's also we have many aspects here. It's only spoken about, here is only one example, abnormalities in the threat, and here is we have two groups, and here is we have listed like common and uncommon diseases. Each one again could be arranged in more complex classification systems. So here is only very simple classification by two groups, just to make understanding of this. So when we talk about concept, it's ordered according to generic relation. And generic relation is relation like AIDS kind of B, pneumonia kind of lung diseases, and pneumonia represent narrow concept, and this represents broader concept. So, and every time we have many such cases. As a result, classification contains concept within certain domain. And the domain can be defined as a set of elements to which variables or function is limited. And any area of interest that might be modeled create information system about. In our case, domain, it will be healthcare area. So healthcare area, it's an entire domain. But within general domain, we can identify many subdomains. And if we talk about healthcare area, so examples of domain reason for encounter, diagnosis, and medical procedures. Again, when I will make some sidestep and made a notice about like example from healthcare area, take a look about, let's say, ICD or National Classification of Diseases. No matter version 9, 10, 11, already 11. Its active version is 11 right now. But it does not changes in general principles, its classification of diseases, and allows one to compare findings collected in different environments. So classification is done according to a single criteria, age. So in this case, we are talking about age as differential criteria. If we pick up another criteria, let's say gender, we will have differential criteria, gender, and so on. So in reality, we could have many differential criteria, many axes of classification. In case of classification diseases, we deal with following aspects, among others, like anatomic location, etiology, morphology, dysfunction, and so on. So as a result, each of these aspects can be used for different orders, and it will be covered as axis of classification, or a simple axis, simply axis. So as a result, at this point, you have to understand that disease classification process, it's really complicated matter because it's even not all axes already listed here. It's only just few examples. So if our classification system limited to one classification principles, it's single axis classification. But most of medical classification system employs many principles of classification, many orders. So it will become multi-axial classification system, which use several ordering principles simultaneously. And nice example, nice and simple example, it will be intestinal classification of primary care, which classify diagnosis along two axes, one for organ system, like of medical character, and one for the components, which usually numerical. I will mention this again later. And we've spoken about this a little bit more. So, about problems when uniform registration of healthcare data, with those assigned classification. It's a lack of common terminology. And there are few things designated to assist in solving this problem. First of all, it will be thesaurus, or a list of terms which is used for certain application area, or domain. So in case of medicine, examples will be list of diagnosis terms or list of terms for laboratory tests. All possible tests. So thesaurus is composed by list of all possible terms. Moreover, in practice, very often we have synonyms. So thesaurus must also contain not only single definition, but it may contain all allowed synonyms for each predefined term. So usually thesaurus is something very huge. Practically, any kind of organization, like starting from single hospital, or this could be also applicable for, let's say, national health system, operate not by full thesaurus, but its limited subset, or so-called controlled vocabulary. It's a restricted set of preferred terms used with the organization for a given purpose. So when we talk about full thesaurus of medical terms, let's say around the world, each country usually limited to some more common set of terms which is appropriate in our condition. And practical implementation, one of the kind of practical implementation, thesaurus, it's nomenclature where we assign code to a medical concept, and medical concept can be combined according to specific rules to form more complex concept. From here, so different classification system and nomenclature is that the former, like classification system, possible codes all are predefined, whereas later, or in nomenclature, user is free to combine codes for all aspects involved. In this case, when we talk about usage of classification system, process of retrieving records for patient whose data fulfill certain classification codes from large databases is relatively easy. In contrast, when we use nomenclature, its process of retrieving records for patient, it's much more difficult because we have high degree of freedom, which already could bring us very complex code. So, for example, we have multi-level classification for medical procedures. Here, we have general definition procedure incision that we show about what kind of tool have to be used, what kind of diagnostic activities has been made, and anatomical side. So here is differential criteria indicated between rectangles here, like action, equipment, aim, twice already, and anatomical side. And membership we will not include here. So here is we can see that specification process, it's actually quite complicated. And then it's important to bring some ordering principles here. I already denoted understanding of terminology, thesaurus, classification, vocabulary, and recurring content system. And here is each one we have. First, provide first list of terms, thesaurus provide ordered terms, synonyms, classification provide member of arrangement, what is part of this, vocabulary give definition, nomenclature composition rule, and current system codes as designators or labels on all of this. And when we talk about medical applications, so one of the first attempts, it had been done in 1933, United States Academy of Medicine. They started with standard classification of diseases. Later, it had been evolved and turned into so-called systematic nomenclature of pathology, which in turn had been used as basis to development systematized nomenclature of human veterinary medicine, or SNOMED, which is example of nomenclature in healthcare area, still active today, and still its primary source of all necessary terminology here. And we compare, as I already mentioned, ICD in a classification of diseases. So what they have in common and what they have a difference between. The SOSNOMED define, as you can see, terminology, it's contained thesaurus, classification, vocabulary, nomenclature, and coding system at all, in total. In contrast, ICD version, all version, including most recent 11, does not contain vocabulary nor nomenclature, and it have only limited thesaurus. So terminology, classification, coding systems, they are common between SNOMED and ICD. But the SNOMED is much broader because it's contained vocabulary and nomenclature, which ICD is lack of it. And then time to dive even slightly deeper to get understanding what is coding itself. So when we talk about coding in general principles, even not specific related to any area, not only limited by medical concepts, it means that we deal with three basic elements, or in so-called semantic triad: object, concept, and term. Objects, or referent, that's particular things in reality, which is exact things we have, like some kind of organ, anatomical element, or some abstract things like mind, theoretical concept, rule, and so on. Concept under coding, it's unit of true or formed by using common properties or set of object, like an organ. And term is designated by linguistic expression of concept or an object in a specific language. So how we call this in, let's say, Polish, English, Polish, Ukrainian, and so on. So here is object. Object, it's concept definition, what is this, and verbal designators according to different languages and so on. So coding, as already mentioned, process assigning of individual object or case to a class or a set of classes in case of multi-axial classification system. In most classification classes are designated by code. So code is in fact interpretation of aspects of an object. So simple coding example, gender coding. In case of two gender, male and female, M and F. Let's say example of coding. Okay, not consider non-binary things, etc. In this point. Different types of code included number code, which could be issued sequentially. Each new class will be given nearest number, so easily added, easily managed. Insecure. Alternative is random numbers, numbers issued randomly. So this case we can create better security solution, but difficult to be added and maintained. No, reservation of classes, for example, if need some specific usage in future. So type of codes, numerical already spoken, mnemonic, formed one of more characters of its related to class rubric. So easily to be memorized, but classification with many classes may lead to either too long codes or codes with no resemblance to class rubrics. Actually, I already shown an example of mnemonic code that coding of gender by MF characters. And here is abbreviation. Abbreviation, like I have already spoken about, HL7, FHIR, etc. So all this abbreviation is also definitely example of mnemonic codes as well. Okay, hierarchical codes, format extendingly an existing code with one or more additional characters in each additional level. So hierarchical code is bears information on the level details of the related class and one of the hierarchical relation with its parent class. So this way of coding bears resemblance to structure of hierarchical classification, and it implies that patient data can be retrieved by using hierarchical codes at certain level, even when significant extension or modification are made at lower levels. So all ICD-9 all ICD version since 9, 10, 11, that's example of hierarchical coding. Here is we have example of ICD-9 in particular with extension for clinical modification. So here is we have. And juxtaposition code. Composition code consists of segments. Each segment provides characteristics of associated class for each additional level of detail. That's, for example, labeling for rooms, which including building, floor, location, and so on. In this case, if we talk about medical application, nice example will be ESPCC, diagnostic code, which is formed by using code consisting of one letter of alphabet, which follow two-digit number. So codes with character D related to tractus digestivus and codes starting with N describe disorder of nervous system and so on. So in case of SPC, we have two independent characteristics are coded closely, and each characteristic has own position in code. So here is we have example of SPCC. When first part represent organ system, second axis represent components. Okay, speaking about how we can encode medical procedures, here is given interesting example. Let's say we consider ordering principle as action, equipment, aim, and chemical sites. Combination 100 sites, 20 action, 10 instruments, paid 5 purpose. It's a result classification system with a potential of 100 classes of codes. So it's extremely complicated, extremely large classification system. Barely, it's hard to imagine that someone will be capable to memorize all these codes and manage it. And even store of such records, it's not easy. So example, it's to cope, it's use combination code. 6-digit combination code consisting of 4 segments, with segments dedicated to action rates, 2 digits, equipment, 2 digits, aim, dynamical sites, respectively. It's also we will distinguish only 135 different codes, which potentially 100,000 combination can be generated. So this time much easily. Here is combination code example. We have here is segments which dedicated for, like, let's say, type of admission, information basic information about wage weight, then some extra segments for each purpose. Так, value additional codes. Yet another principles of coding. Generate only power of 2 used to represent a data item of class. So several characteristics can be coded, but only one number instead of segments for each characteristics used as code. So in compared to previous, we have defined segments. Here is we use one number. Okay, presence of absence some risk factors. Let's say power of 0, it will be smoker, no smoker. Power of 1, it will be overweight or no overweight. And the power of 4 can increase cholesterol, etc. So with codes 1 to 7, we can summarize our 3 risks. But reconstruction of original records this way impossible without usage of digital computer system. So that's consequence. Very effective, very condensed, but reconstruction impossible for human management. But again, practically, where it's widely used, it's barcodes and QR codes. So that things exactly made to value additional codes. And obviously, we need only digital system to read and decode it. But here is how it's made. Okay, now move forward into summary. So it's theoretical study of classification, included basic principles, procedures, rules. And it's concerned with classification in general, and then classification used at the end of products of the design process. So it's actually field of study, which is concerned with classification problems in general, with development of classification system. And let's say example of cognitive taxonomy of medical errors here when we have slips and mistakes, it's considering just only human errors and divided into classes, 4 subclasses, and so on. Another theoretical area for studying is nosology, or defined as the science of classification of diseases. And we have to understand that nosology and nosography appears, and they are different things, because nosography is science of description of diseases. And here is again, here is we spoken about very core things. Difference between definition and description. Definition gives essential characteristics of the diseases, and description include accidental characteristics. Okay, and now it's time to get into overview of most common medical classification system. I have already mentioned at least half of this, like ACD, SPCC, SNOMED. So it will be like brief again summary, and then I will add another 3 to just get some. Actually, it's not all. We have much more. About like objective, why it's important, why it's have to be processed. It's just like example, again, a little bit outdated flowchart from United States, which depict the relationship between different classification system and organization structure, and what it has to be done, which forms have to be filled, and which order, who is owner, who is responsible to processing these documents in order to complete necessary paperwork for patient, processing patient within hospital. So in fact, we are talking about very complicated matter, which is important in case of creating all necessary document in order, and processing, especially if we talk about billings, insurances, etc. Okay, ICD. National Classification Diseases, archetypal coding system for patient records abstraction. First edition published more than 100 years ago, well before first digital computer can be made. And revised usually, okay, here is we have slightly some little mistakes here. Most recent version is ICD-11. ICD-11, 12 still in development. Oh, it will be appear. I already mentioned that consists of core classifications, 3-digit code, which are minimum requirements for reporting entities to World Health Organization. Optional 4-digit provides for additional detail, and we have some reservation of numbers for specific details, and so on. So, basically means to be used for coding of diseases. In both cases, SD910 contains set of extension for other families of medical terms. Disease codes for both for 3 ICD-9, 10, 11 grouped into chapters. And here is we have difference between ICD-9 and modern ICD-10, 11. So it's only numerical codes in ICD-9, but we have extension with characters in ICD-10 and 11 here. No, of course, United States already used clinical modification ICD-9, 10 CM. Don't know if they have 11 CM already. And here is example I have already shown about ICD-9. And okay, clinical modification version of under some kind of United States software. Okay, ICPC had been produced by the Organization of National Colleges, academics, in general physician, a family physician, represent two Excel system, represented by two Excel system. First Excel, already spoken, that's orientation to body system tracts, coded by letter, and second axis, coded by 2 digits and contains 7 code groups. Here is given example, pneumonia, how could be encoded respiratory tracts and diagnostic component. It's actually major benefits. It's ICPC used to encode encounters according to the principles of subjective information, complaints, subjective information, test lab results, assessment, diagnosis, and P stands for plan or diagnostics test, treatments, etc. Here is we have example of ICPC, also I have already shown. SNOMED. This time I'm talking about nomenclature and not coding system. First published 1975, then review from time to time. The current version is international, SNOMED International, has 11 axes or modules, and each this axis forms complete hierarchical classification system. So it's combination of 11 hierarchical classification system generally. And in case of diagnosis, SNOMED may consist of topographic code, morphology code, living organic code, function code. So well-defined diagnosis for a combination of 3 or 4 codes exist. Decay diagnosis codes defined. Here is we have, let's say, the same pneumococcal pneumonia. Here is we have by diagnosis model, it will be given D-based code, but it's equivalent to the combination of like topology code for lung, or morphology code information, or living organism axis, streptococcus code, and so on. So the same things could be encoded in different way in nomenclature system. And here is we have only listed axis for SNOMED, only listed axis, so basic axis we have here. And here is again how we can organize, how we can represent structure and necessary components to depict our diseases within our SNOMED. Okay, DRG. or diagnosis-related groups. Classification again bases on clinical modification of ICD-9, and they actually extend ICD coding system to by factors that affect the cost treatment and when staying in hospital, such as severity, complication, type of treatment, and so on. Actually, mostly used for budgeting when we need to calculate cost treatment. And here is we have the DRG example. So actually, that's not complete example because it has to contain at least one column at the right side or a price of this kind of service. But it's specific to hospital, definitely. Okay, MESH. Medical Subject Hearing Classification, developed and maintained by National Library of Medicine in the United States. Actually, it's background of PubMed. So generally used to index for the medical literature. As an hierarchy of mesh, a concept may appear as a narrower concept of more than one broader concept. So pneumonia listed as a respiratory tract infection as well as lung diseases. And here is we could see example of mesh structure. And here is how we can make search for this, like documents published for these diseases. Just check this checkbox and start search PubMed. And here is will be PubMed Advanced. Here is we have a PubMed Advanced search to mesh to. Okay. And probably last things I want to show for you, it's ATC, anatomical therapeutic chemical codes that's developed for systematic and hierarchical classification of drugs and medicines. So it's acronym for anatomical organ system in the body for which drug is given, therapeutic purpose for which the drug is used, and chemical class to which drug belongs. So it started in Norway in 1970 when like initial classification had been proposed. Then it had been adopted by World Health Organization, especially Drug Regulation Research Group, and again maintained by now but World Health Organization. But still headquarters in Norway. An advantage of usage ETC, it's identified drug products, including active substance, the route of admission, along relevant like dosings and so on. Therapeutically as well as chemically oriented features, that's most system-like, hierarchical structures allows the logical grouping, and it's accepts international World Health standards to drug regulation research. Of course, not cover everything, like combinational products, dermatological preparation, local compounding preparation, etc. But by the time now, like most of drugs already had, most of medicine already had, that's ATC equivalent. And if you clearly know that ATC code, you can get this medicine in different country under different generic name. Just by ITC code, you will be ensured that it's like here is we have to talk about furosemide when we can use this code like mostly all around the world in most well-developed and most of developmental countries to retrieve equivalent of this medicine. So here is we have. Okay, that's actually all for today. I have intention to present for you, like made emphasis about overlapping classification, not the coding analysis, but also the classification of medical events. and present some example of most common worldwide used medical information, medical coding classification systems. Thank you for your attention. Goodbye.